Yeah, good evening, everyone. Good evening. Check is audio video okay or not? Verify. Yeah, can we start? Please give signal. Can we start or not? What is the today's date? What is the today's date? I think around 23. 23, 10, 25. It's 23, 24. Please check. Verify everyone. Is 23 or 24? Check one time. Yeah, 23 only. Fine. Perfect. Perfect. So today is 23, 10, 25 is the date 23, 10, 25. So this is the first problem. Which one of the following kinds of derivation is used by LR parser? Everyone know LR parser means bottom up parser. LR parser means bottom up parser. Bottom up parser. LR parser means bottom up parser. Right? I think everyone know bottom up parser follows, right? So normally from the bottom, if you see no derivation, but if you see the bottom of parser in the reverse order, it look like a rightmost derivation. Remember, rightmost derivation in the reverse order. If anyone say rightmost, wrong. So because from the bottom, if you see no derivation. To be frank, from the bottom, if you see no derivation. If you see from bottom no derivation, bottom of parser see in the reverse order. It look like a rightmost derivation. Remember everyone, no parser follows rightmost derivation. Because when you are reading from left to right, derivation should also be left to right. But bottom of parser is from the bottom. But if you see in the reverse order, it look like a rightmost derivation. Rightmost derivation in the reverse order. Rightmost derivation in the reverse order. For this question, answer is going to be rightmost derivation in the reverse order. This is the answer for this. Let me know if anyone having any issue. For this problem, answer is rightmost derivation in the reverse order. Rightmost derivation in the reverse order. Please be careful. Right? I hope everyone is fine. Let me know anyone having any issue. Small doubt also there. Ready, sir? I have this issue. I have that issue. You say to me, I am going to help you. To this problem, answer is fourth option. Top down follows leftmost derivation. There is no meaning of leftmost in the reverse order, right? Rightmost, there is no meaning, you know very well. Rightmost in the reverse order. Rightmost in the reverse order is the best one for the bottom up parsers. I am writing also bottom up parsers. Bottom up parsers follows rightmost derivation. Reverse order, rightmost derivation. Top down parser, if you observe, top down parsers if you observe, it is a leftmost derivation. Top down parser, right? If you see, right? So leftmost derivation, no reverse order, nothing. Leftmost derivation. Check properly. The answer for this problem is going to be right. So fourth option. Fourth option. Anyone having any objection, please let me know. Reddy sir, I have this objection. You let me know. I will help you. So question number, right? Question number 100 answer is going to be fourth option. Can you go to question number 101? It is an interesting problem. Question number 101. It is an interesting problem. Can you try this? Can you try this? Already 100 problems we are already covered. 100 problems already we covered. It is there in the right EPT portal. EPT portal already 100 problems are there. Right? So it is a 101 problem. It is a 101 problem. 100 we done. It is a 101 problem. Can you try this one? Consider the grammar with non-terminal. N is equal to S, C, S1. Terminals T, right? Terminals A, B, and D. With the S as the start symbol and the following set of rules. These are the grammar productions which are given. These are the grammar productions which are given. So using this grammar, right, please verify which options are right or wrong. Please go ahead, right, try once. I'm expecting answer from all of you. Please try, everyone. Everyone try this. I'm expecting answer from all of you. I will be here only, please try. I will be here only, please try. Yeah, please let me know what is the answer for this. Maybe you got the answer. What is the answer? Yeah, I think everyone know it is an ambiguous grammar. This grammar, if you observe, it is an ambiguous grammar. This is called dangling if-else problem. This is called dangling if else problem, right? If you want, you can see this. See this one. If you want, you can see this. Dangling if else problem. It is something like this. It is something like this one. If some condition, I means if some condition, right? C means some condition. It is a dangling else problem, right? I means if, right? C means condition, okay? If condition is true, then some statement, yes, else, right? I think see this one. S1 goes to else, ES, again statement. So this is the actual dangling else problem. This is called dangling else problem, right? So S1 is else statement. This S means statement, T means then, C means condition. So if it's a, I think right, dangling if else problem. Dangling if else problem. So I will give one small string here. Let's see this one. See everyone. If the input string is IBT, I think C goes to B, right? IBT. Next one is EA. If the input is like this, IBT, EA. IBT, EA, right? Now if you want to verify two parse trees, see everyone, S goes to, right? I, C, T, S, S1, S goes to, one more time substitute, I, C, T, S, S1, S goes to ICT, SS1, S goes to ICT, SS1, right? So C goes to B. And again, this C also going to be B. So if you see IBT, now I think lastly, if you observe, yes, S1 is there. Yes, the S1 is there. Now if you observe clearly, so you want EA. Careful, you want EA. This S replaced by, let me check. IBT, again IBT, yes, the S1, let us assume that, right? AEA. Let us assume that is the AEA. We want one string, right? I am writing AEA. So this S goes to A. IBT, A came. Now in the SS1, if you observe clearly, this S1 also, you can replace this S1 also. Let us assume that this S1 is epsilon. This S1 is going to be, ES. This ES replaced by A. This is the one option. To generate EA, this is the one tree. One more way is, I think this S1 you can make as S, right? This S1 you can make it as ES. This S1 you can make it as ES, right? That one you can make epsilon. That's the one more parse tree. To these two parse trees is possible. One more I'm writing. S goes to ICT. S goes to ICT. SS1. S1 goes to, again same story. ICT. SS1. Right? So this is going to be IBT. This is also IBT. So this S is going to be A. That is also okay. This S replaced by ES. S replaced by A. This S1 replaced by epsilon. This S1 replaced by epsilon. So over. So two parse trees are there. This is called dangling else problem. Dangling if else problem. This is called dangling if else problem. It's ambiguous grammar. Please remember this. It's a very, very important one. It's a dangling if else problem. It's a dangling if else problem. Suppose if you don't want else. Suppose if you don't want else. S1 replaced by epsilon. If you don't want else, S1 replaced by epsilon. S1 replaced by epsilon. If you don't want else, S1 replaced by epsilon. If you want else, S1 replaced by ES. Yeah, it's one of the famous grammar. It is a dangling if else problem. Dangling if else problem. So there is a dilemma, right? Whether I have to go to first approach, whether I have to go to second approach, there is a dilemma. So it is an ambiguous grammar. Please remember everyone. It's one of the famous grammar, which is the dangling else, dangling if else problem. Yeah, can you go to next one? 102 problem. Can you go to 102 problem? What is the answer? Find the number of SR and RR conflicts in LR0 parser. Find the number of SR and RR conflicts in LR0 parser. LR0 parser, nothing there here. Just you have to do one time. You have to do one time. Right? So LR0 parser. Remember LR0 parser. So I will do once. How many SR and RR conflicts are there? Right? I will do once. See the grammar. S dash goes to dot S. Be careful. There is no look ahead symbols because it is a LR0 parser. Dot S. S goes to dot SS. All S productions you have to write. Dot A. Dot epsilon means dot. Right? Fine. That is until now everything is fine. Now on this state, if I give S as input, let me check. On this state, if I give S as input, then what happened is, if I give S as input, S dash goes to S dot, it will go. S goes to S dot S, right? S dot S. If I give S as input, S goes to S dot. S goes to S dot S. Because of dot S, S goes to dot SS dot A dot epsilon means dot. This is I0. This is I1. Next one, on the state, if I give S as input, it will go to S goes to SS dot, right? If I give S as input, it will also increase, it will also. S goes to S dot S. Because of dot S, S possibilities all will come. Dot SS dot A dot epsilon. Right? Please check. If any two states are same, please let me know. It is I2. If you give A, there is nothing. Only one person means no need to write. Leave it. Right? Only one person, no need to write. So S is over, right? Only A, no need to write it. Right? Next one. On the state, if I give S, I think it will go itself. It will goes to SS dot. Same story will happen. Right? A, I think same story. It will go to same story. Only one production, no need to think that much. Remember, it is a LR0 parser. Everyone observe, LR0 parser. How many SR conflict, how many RR conflicts? Observe everyone. How many SR conflict, how many RR conflicts? How many SR, how many RR? Right? I think if you observe clearly, listen. If you observe clearly on I0 state, by giving terminal means action part will come. Because of this, action will come. Because of terminal, action will come. And one more thing is, one production already reduced. This production is reduced. Production number 1, production number 2, production number 3. So what I mean to say is, in the I0, already one SR. Action means shift entry. This one. This is reduce entry. So I0 already, let me write now. I0 state. I0 state, if you observe clearly, I0 state, if you observe clearly, at A already shift there. At A already shift there. There is a reduce also in I0. Production number 3, R3. Suppose assume that the state number is I4. This is S4. This is S4. If anyone don't know, if anyone is forgotten, I request you all the people please visit one time. S4 R3. At A already, at I0, shift reduce conflict already there because of this reduce everywhere. Because of this reduce everywhere. At A, shift reduce conflict is already there. Okay. At A, only one conflict because two reduce not there. Two reduce not there. So one SR already confirmed. I0, one SR confirmed. What about I1? Let's go to I1. In the I1, what is happening? Let's check. In the I1, if you observe, there is someone going outside by reading terminal, shift will come. And the important thing is there is no reduce. It is a series one. It is augmented production, no need to bother that much. It is augmented production, there is no need to bother that much. So because of this one reduce, because of this one reduce, because of this shift, right? I think one SR, S4 again, R3, same story. So in the I1 also, one shift, one reduce, one SR conflict. I1 also, one SR. Please check if I am doing anything wrong. Yeah, no problem. Let's go to I2 state. Let's go to I2 state. If I done anything wrong, please rectify. If I do anything wrong, please rectify. Now, if you go to the I2 state, everyone observe. I2 state, if you observe, I think as usual, one shift, right? One SR there. As usual, one SR is there. And one more important thing is one SR is there, that's okay. One RR also there. See this one, right? And one RR also there. One RR also there. And one more thing is between this shift to between this reduce and between this shift to one more SR. So I will do one by one. At A already S3, S4. At A already S4. At A already S4. What about reduce? I think this production is reduced to R3. This production also reduced to R1. Let me write now. R3 also and R1 also there. So I think it is going to be shift reduce conflict also, reduce conflict also there. But I think it is overall if you observe three conflicts are there here. S4 R3 is one thing. One more thing is S4 R1 is one more. One more thing is R1 R3. R1 R3, one more. So one shift reduce, one more shift reduce, one RR. I think previously one shift reduce, one more shift reduce. So total 4 shift reduce, one RR. Option E 4, 1. Check if I done anything wrong. Yeah, check if I done anything wrong. Anything wrong I done, please let me know. In the last I2, one S4 is there, 2 reduce there. S4 R3, 1 SR, S4 R1, 1 more SR, R3 R1, 1 more RR, totally 1 RR, 4 SR. Please check here. I'm thinking 4-1. In the available option, maybe you can select 3-1. Reduce is only one reduce. Check. Reduce is only one reduce. In the I2, between R1, between R3, 1 RR. Ella, please let me know. So what is asking? Number of states Find the number of SR-RR conflicts. I think in the I2 there are 3 combinations. Out of 3 people selecting 2 people, 3C2, 3 ways. In the I2 state, out of 3 people selecting 2 people. 2 reduce and one shift is there. Out of 3 people selecting 2 people, 3C2, 3 ways are there. So in the last state itself 3 came. 2 SR, 1 RR. Before that 2 SR. So totally 4 SR and 1 RR. Let me know. Yala, can I move to next problem? Can I move to next problem? Find the number of SR and RR conflicts in LR0 parser. Hello? 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 Can we move next? Can we move next? Question number 102, answer is E, 41, 4 SR, 1 RR, 4 SR and 1 RR. Can we move to next? Nowhere I seen 2 RR. 2 RR, no chance. 2 RR, no chance. Don't worry anything about option. I given randomly some options. Check if any 2 states are same. Check if any 2 states are same. Yeah, I think perfect. We can move to the next problem. This problem already we done. Right? Question number 103. What is the answer? Question number 103. What is the answer? Question number 103. What is the answer? Check true or false about dynamic type checking. We done in the previous classes. What is the answer? Dynamic type checking means type checking is done during execution. True. Next one, it increases the cost of execution. Yes. If running means what? Running means if it is a recursive program, same thing you will run again and again. Same type checking again and again you are doing. One time type checking is enough. Many times what are you doing? If you do type checking at runtime, that is a problem. If you do type checking, all errors are not possible because if and else condition is there, so if true, else will not execute. In the else, there are some type errors. You may not able to reach it. If condition is true, you don't go to else. Right? If only you are executing. Else having some issues you may not see. That is the problem if you go runtime. Running area only will check. You don't check every area. So if is true, if part only will check. If part only will do type checking. Else part you may not do type checking where type errors are available. So all the type errors are detected is wrong. He is asking, right? True, false. A, B true, C false. I think everything we done. Yeah, let's go to next one. This one also we done. It is actually TOC1. This is actually TOC1. So I will repeat one time. This is actually TOC1. I will repeat one time. Right? It will take 1 or 2 minutes only. I will repeat one time. Can you see this one? A is polynomially reduced to B. A is polynomially reduced to B. If A is undecidable, B also undecidable. If A is right non-REL, B also non-REL. B also non-REL. Right? If A is non-REC, So B also non-REC. If A is NPH, B also NPH. If A is NPC, B also NPC. Remember, these all will happen left to right. Many times I said, one more time I am saying. Right? Next one. Same thing. If right is done, left also. Suppose let me write here. If right is decidable, left also decidable. If right is REL, left also REL. If right is REC, left also REC. Left also REC. Right? Fine. That's okay. I think same problem. I will read one time. P1 is reducible to P3. What is the P1? P1 is decidable, P2 is undecidable. P1 is reducible to P3. If P1 is decidable, P3 is decidable. No, decidable will start from right. So it cannot. If you go to the B, P3 is reducible to P2. What is the P3? Undecidable. P3 is reducible to P2. What is the P2? Undecidable. Undecidable will be from the left, so it is not. Next one. P2 is reducible to P3. P2 is undecidable. Undecidable reducible to P3. P3 also undecidable. So P3 undecidable, true. Next one. P2 complement. Undecidable complement is undecidable. Please remember this. Undecidable complement is undecidable. If P3 is reducible to undecidable, undecidable will work from left side but not from right side. So it is false. So answer is C. Everyone know this. Answer is C. Everyone know this. Right? Fine. Perfect. Answer for this one is C. Yeah. What about this one? This is very simple. Everyone check one time. Answer is C. This is very simple. Everyone check this because there is a grammar which is the ambiguous grammar. There is one grammar which is the ambiguous grammar. Right? You done the right conversion from ambiguous to unambiguous. Right? It is the ambiguous grammar. It is the equivalent unambiguous grammar. So if you see the language, because of it is the equivalent one, both the languages are same. That's what he is asking. For the given ambiguous grammar, I written the equivalent unambiguous grammar. What about language? Both are equal. Right? This is the question number 104. Go to the question number, right? Question number 105. Go to the question number 105. What is the answer? Hi, Rahul. Hi. Go to the question number 105. What is question number 105? The grammar S goes to ASA, BS, or C. I think you can verify if you can verify LL1 or not. In the S row, A place, first production will go. B place, second production will go. C place, third production will go. So it is LL1. LL1 means LR1 also. Top down parser satisfy means bottom up parser also will satisfy. Both. C is the answer. Right? C is the answer. Everyone know this. Top down parser satisfying means bottom up parser also will satisfy. Top down satisfying, bottom up also satisfy. How to check LL1? In the classroom, we done many problems. 20 problems in the classroom I done. 20 problems I done in the classroom for LL1. LR1 I done the 20 more problems. Right? Please verify. So this is going to be both LL1 and LR1. LL1 means LR1 also. Right? LL1 is the subset, LR1 is the superset. LL1 is here. LR1 is here. LL1 is subset of LR1. LL1 satisfied means LR1 also will satisfy. LL1 satisfied means LR1 also satisfied. Right? Check properly. LL1 satisfied. LR1 also will satisfy. Because of you are really comfortable, because of the grammar is S goes to A, C, B, S, or C, is LL1. LL1 means LR1 also. Okay, fine. Answer is C. Let's go to right 106. Let's go to 106. Heap allocation. Heap allocation means the dynamic data structures. If you want recursion, right, stack is enough. If you want recursion, stack is enough. If you want a dynamic data structure, heap allocation required. Heap allocation required. Which languages, right? Which languages necessarily need heap allocation in the runtime environment? Those that allow dynamic data structure. Yeah, we did this, right? Yeah. So, right, means in the last class, I think some small technical issues. So that is the reason I just want to repeat one time. Right? Those people who are affected little bit, they can go through it one time. So question number 106, answer is C. Right? Heap allocation if you want dynamic data structure. Stack, right? If you want the recursion, stack allocation. Right? Recursion if you want stack allocation. If you want dynamic data structure, heap allocation. Right? Fine. Yeah. So can you see this one? Which one of the following is true for the left recursive grammar? Left recursion is there, right? It causes the recursive descent parser loop forever. Option A. Option A. Top-down parser having problem with the left recursive grammar. A is the answer. A is the answer. With the top-down parser having problem with the left recursion. Bottom-up parser don't have any issue. Right? If at all, if you want to select one option, select option A. If at all it is a MSQ, not suitable for parsing, maybe you can select option D also if it is MSQ. Right? Most probable answer is going to be option A because top-down parsers are having problem with the left recursion. Bottom-up parser don't have any issue. But anyhow, not suitable for parsing. Top-down parsing, no problem. So top-down parser having problem, right? Bottom-up parser don't have any problem. With the MCQ, you can select A. MSQ, maybe you can select A and D also. Yeah, go to the next one. Consider a state of an LR0 parser containing following two items only. Remember, in LR0 parser, in one of the state, these two are there. Please be careful. In LR0 parser, in one of the state, these two people are there. What kind of problems it can come? One production reduced, but after dot, there is no terminal. Variable is there. No SR. See here, because of two reduce not there, in this state, two reduce not there, RR conflict, no chance. Two reduce not there, RR conflict, no chance. Right? And one more. After dot, there is no terminal. SR also no chance. Shift is not possible. Shift is not possible. Two reduce not there, RR not possible. After dot, there is no terminal. Shift also not possible. So no RR problem, no SR problem. Which one of the following is true? There is a shift reduce conflict in the parsing table. No. Right? The given grammar is not LR0. No, it is LR0 because there is no chance of RR, there is no chance of SR. There is a reduce conflict. No. The go-to function on symbol B must lead to some other state. Must lead to some other state. The go-to function on symbol B must lead to some other state. Yes. So he's asking which of the following is true? I think D is the answer. Now can you go ahead? What is the answer for this? Can you go ahead? What is the answer for this? Try everyone. Everyone try. Everyone try. Try this problem. Which one of the following statement is false? Which one of the following statement is false? Go ahead. Everyone try. Which one of the following statement is false? Is asking. False. In statically typed language, each variable in a program has fixed type. You know that is the meaning of statically typed languages. True. In untyped languages, values do not have any types. True. In dynamically typed language, variables having no types. No. Types are there but keep on changing. Right. Next one. In all statically typed language, each variable in a program is associated with the values of only single type during execution of the program. Yes. So, which is false is asking. C is false. In dynamically typed languages, variables having types, but they will keep on change. They will keep on change. Are you getting? They will keep on changing. In dynamical typed language, variables having types, they will keep on change. In untyped languages, values do not have any types. Python is a dynamically typed language because the types are keep on changing. Statically typed languages means when it is something like a variable you declared as static. Total lifetime, same type will be there. Something like static variable. Something like static variable. In statically typed languages, each variable in a program has a fixed type. Yeah, in untyped means no types are there. In untyped languages, values do not have any type. In dynamically typed language, variables having types, but they will keep on change. Sometimes you can store integer, sometimes you can store character, sometimes you can store float. Statically typed language means only one type. It is something like C programming. Statically typed languages, something like C programming. Python is a dynamic. In Python, so in Python, if you say a is equal to 10, in Python you done the a is equal to 10. Just type, right? Type of a you check, it will become integer. Right? Afterwards, a is equal to 10.5 you store. Then try the type of a, it will say float. Then after some time you can write a is equal to some character you keep. Type of a, it will say character. So in Python language, a variable having different types. In C language, total program contain one person, one type only. Fine. Of course, that is mean, see, in variable only you are storing value, right? In variable only you are storing value, right? A is equal to 20. A is equal to 20. A is a variable. Variable type is integer. Afterwards, A is equal to 10.5. A is a variable. A type is float. C language is statically typed language. Python is a dynamically typed language. Okay, can we move to next? Can we move to next? Right, perfect. Yeah, can you see this one? Question number 110. Question number 110. Which data structure in a compiler is used for managing information about variables and attributes? Variable and its attributes means what is a variable type, what is a variable value, something like that. I think symbol table. I think symbol table. Which data structure in a compiler is used for managing information about variables and their attributes? Variable and their attribute. Attribute in the sense, what is the type of a variable? What is the scope of a variable? What are the values of a variable? So variable name and variable type, variable scope and variable value, something like that. Symbol table. Symbol table. Yeah. Question number 111. Question number 111. Can you check here? How many reductions will happen using bottom up to the string $b dot ag? How many reductions? How you find out reductions? How you find out reductions? How you find out reduction? Remember, simply draw the tree. Simply draw the tree, right? From bottom to top, if you read, which is nothing but a one reduction. From top to bottom, if you read, that is called expansion. From bottom to top, if you read, that is called as reduction. Yeah, right. Every production, whatever is there, that is the right. If you read the top to bottom, expansion, bottom to top, that is called as right reduction. So I will try. This is the string. This is the string. Can you give one parse tree? Can you give one parse tree to generate this particular string? A at the date b dollar dot ag. A at the date b dollar dot ag. Can you give one tree? S goes to SA. S goes to SA. S replaced by A maybe. A goes to at the date SB. S replaced by B. B goes to B dollar, where B replaced by epsilon maybe. Check properly. So I will try one tree. I will try one tree. S goes to SA. This S replaced by A. Let me draw one tree. Let me draw one tree. A goes to at the date SB. S goes to B. B goes to, right? Be careful. B goes to yeah. What should I write now? S goes to B. So B goes to what should I write? Can I write B goes to B dollar? So someone is saying B replaced by, let me write. B replaced by dot SAG. Is it so? Check one time. A goes to at the date SB. S goes to B. I return. Hello. Please let me know. B goes to dot SAG. I don't think so. Okay. So lastly G came. So until here it came. So how to get? Dollar. S goes to SA. S replaced by B. A replaced by B dollar. A replaced by B dollar. Let me finish it up. Let me finish it up. B dollar. B replaced by epsilon. Dollar is there. Dot is there. A is there. Epsilon there. Is it okay? Now verify. Is it okay? A at the date B dollar dot AG. Is it perfect? So the tree whichever I drawn, is it correct or not? The tree whichever I drawn, is it correct or not? S goes to SA. S replaced by A. A replaced by at the date SB. S replaced by SA. Right? S replaced by B. A replaced by B dollar. B replaced by epsilon. B replaced by dot SAG. S replaced by A by epsilon G. Whatever tree I drawn, is it right or wrong? Whatever tree I drawn, is it right or wrong? There may be a one more way. Don't worry. There may be a one more way. Whatever I drawn, is it right or wrong? Make it fast. Everyone say, whatever tree I drawn, is it right or wrong? Arey, make it fast, yaar. Coming and not talking. What is this? Coming and not talking. What is this, yaar? Hello? Can we stop the class then? So one tree I written. There may be many trees. See, I written also within the brackets. See, multiple parts trees possible. To this grammar, unknowingly, multiple parts trees possible. Okay, one tree we written. Okay, remember, see this one. From the bottom you go. Every production is one reduction. It is a one reduction. It is a one more reduction. It is a one more reduction. It is a reduction number one. It is the first reduction. From left count. From the bottom left count. First reduction. It is the second reduction. It is the third reduction. It is the fourth reduction. It is the fifth reduction. It is the sixth reduction. It is the seventh reduction. Every production is a reduction. It is the eighth reduction. It is the ninth reduction. It is the 10th reduction. So to this tree, we got 10 reductions. To this tree, we got 10 reductions. And the important thing is, in the examination, this question is given. In the examination, this question is given. So remember, most probably one tree only possible. If different tree, different number of productions may be required. That time multiple answers will be there. If at all this question is given, only one tree normally possible. If at all multiple trees are possible, one option is there. Multiple trees possible, answer is undefined. Then you have to select multiple trees possible, answer is undefined. Normally, this, right, if at all any question is given like this, just draw the tree, how many productions are there, count it. Draw the tree, how many productions are there, count it. So if you want to know a real number, right, from left to right, you start for every production from the bottom. Left to right, you do from the bottom. So these are the numbers, whatever way I given, like that it will normally will happen. Totally 10 productions are used. So 10 reductions are there. If you say, sir, one more tree possible, maybe one more answer also possible. So normally, if this question is given in the examination, mostly one tree possible. In the option, if at all multiple trees are there, please check properly. There may be a chance that multiple trees also may be possible. To this problem, in one of the class while doing, one student said one more tree possible. That is the reason I written multiple trees possible. Yeah, counting number of reductions is nothing but just draw the tree. Just draw the tree, count how many productions are there. From the bottom, can you see this one? S goes to, S is replaced by A. This is called expansion. A replaced by S. This is called reduction. From the bottom, if you do, that is called reduction. From the top, if you do, that is called expansion. In the top-down parser, you will do expansion. In the bottom of parser, you will do reduction. In the bottom of parser, you will do reduction. In the top-down parser, you will do expansion. Top-down parser, you will do expansion. In the bottom of parser, you will do reduction. How many productions are there in this tree? Those many reductions are there. Terminology will differ, but right, actual topic is same. To this one, I written 10 for this tree. If anyone say one more tree possible, see, someone already mentioned multiple trees possible, then multiple answers. You may see one more option, multiple answers are possible, result is undefined. Maybe you have to select result is undefined. Normally, this question will be asked for unambiguous grammar only. This question will be asked for unambiguous grammar only. Please try to understand. Ambiguous grammar, they cannot ask because multiple answers will be possible. So one tree I written, answer is 10. If anyone say one more tree possible and answer may be something like a 9, then answer is multiple trees possible, answer is undefined. But I want to convey in this problem how to find out number of reductions. More than that, I don't want to say anything. Number of productions which are there in the tree, which is equal to number of reductions. Okay, that's perfect. Go to the, can you go to the question number 112? Question number 112. How many reductions will happen using bottom of parser to the string? Is it same? Can you check? Is it different? Is it same? Here also you don't worry that much about. You don't worry that much about. You don't worry that much about, right? How many trees possible? If at all multiple trees are there, one of the option contain multiple trees, answer is undefined. Then only think about multiple trees. If no option like that, just find out one tree and complete it. Is it same like previous problem? In the previous problem, S goes to SA or A or B. But here S goes to DA, A goes to A dot at the date SB, B dollar and epsilon. B goes to dot SAG or epsilon. D goes to AB. D goes to AB. Can you check? Can you check? Can you draw one tree? Don't worry about how many trees. Option contain multiple answer. Then only check multiple trees. Just to find out one tree. S goes to DA. S goes to DA. Yeah, S goes to DA. Yeah, fine, that's okay. S goes to DA. Can you complete the tree? Can you complete the tree? S goes to DA. D goes to A. Okay. D goes to A. That's okay. A goes to at the date SB. S goes to DA. D goes to B. A goes to B dollar. B goes to maybe epsilon. So until now, A at the date B, A at the date B followed by dollar. So B replaced by dot SAG. S replaced by DA. D replaced by A. A replaced by epsilon. A replaced by epsilon G. Can you help me now? Here multiple trees possible or one tree? I'm thinking that only one tree. That is the change what I done. Please verify properly. So A came, okay. At the date came, okay. B came, okay. After B, I think there is a dollar. Yes. Afterwards dot. Afterwards A. Afterwards G. Yes. So if you see the number of productions, 1 here, 2 here, 3 here, 4 here, 5 here, I think 6 here, 7 here, 8 here, 9 here, 10 here, 11 here, 12 here. So remember in the tree how many productions are there? Those many. In the tree how many productions are there? Those many. Fine, is it okay? In the tree how many productions are there? Those many. That is nothing but number of reductions. Simply draw one tree. If multiple trees are there, see the option. Multiple answers possible. Then only think about one more tree. Otherwise, don't bother. To confuse you, you may say bottom up. To confuse you, you may say top down. To confuse you, you may say bottom up. To confuse you, you may say top down. Don't confuse. You draw any tree. Because no one will see you. Are you doing from top? Are you doing from bottom? Only kids will cry. By seeing bottom up. By seeing bottom up, kids will cry. So I have to do from bottom, right? I have to do from top. They will confuse you by mentioning top down. They will confuse you by mentioning bottom up. You no need to confuse. Draw one tree. How many productions are there? Please check. The concept of reductions will come only in the bottom up. That's the reason you use using bottom up. Right? The concept of reductions will come only in bottom up. That's the reason he is using bottom up. Fine. Someone is saying D goes to A or B. Yes. D goes to A or B. If you want, you can check. If you want, you can check. Everywhere I use D goes to A or B. Either A used or B used. D goes to either A or B. It is not AB. It is a A or B. D goes to A or B. Yeah, D goes to A or B. That is the meaning of D goes to A or B, right? D place you can take A also, D place you can take B also. Whatever you want, you can take. If you take D goes to A, that is a one reduction. If you goes to D goes to B, that is a one more. See, somewhere I use D goes to A, one reduction. Somewhere I use D goes to B, one more reduction. In the tree, how many productions you will use? Those many reductions. You may repeat it. You can take, right, depending upon your choice, right? See, somewhere I have to take D to A. Somewhere I have to take D to B. So you have to consider whatever you taken in the tree, you have to consider both. Yes, whatever you taken. So see, somewhere I taken D to A. One I consider. Somewhere I taken D to B. One I consider. Some places D to B I taken. Some places D to A I taken. So two productions I taken. At a time, one. True. D having two choices. At that place, which choice you used? That is one. D goes to A, D goes to B. At some place, D goes to A, I taken one. At some places, I taken D goes to B, one more one. Like that. A contain three people. A contain three people. So, different places, I used the A different ways. One place, I written A goes to at the date SP, one production. At one place, I written A goes to B dollar, one more production. At one place, I written A goes to epsilon, one more production. Right? Everywhere, A having three choices, you take whatever you like. At a time, you cannot take all, right? At a time, you cannot take all. You have three choices, take whatever you like. So totally in this tree, 12 productions are there. So 12 reductions. 12 reductions are there, right? Let's go to question number 113. Question number 113, right? One of the purpose of using intermediate code in compiler, the purpose of intermediate code is increase the chances of reusing the machine independent code. Optimizer in the other compilers. Means it will create the machine independent code, everyone know. Increase the chances of reusing the machine independent code. Optimizer in other compiler. The purpose of intermediate code is machine independent code it will create. Machine independent code it will create. Improve the register allocation. That is, I think, something related to, right, target code. Make parsing and semantic analysis simple. That is not, I think, after those pages intermediate code will come. How parsing and semantic simple. Improve error recovery and error reporting. No relation. So answer is, I think, 3. Question number 1133. Question number 114. Question number 114. In the context of compiler, which of the following is not an intermediate representation of source program? Intermediate representation of source program which is not. 3 address code is one of the representation of intermediate code. Syntax tree is one of the representation of intermediate code. Flow control graph, that is also one of the representation of intermediate code. Symbol table is not. Symbol table is not. Which one of the following is not? So fourth one. Control flow graph, CFG. CFG will be used. CFG will be made for intermediate code only. It's one more way of graph format you are representing. If you represent the 3 address code in the form of a graph, right, that is going to be control flow graph. So answer is 1, 2, 3 is a representation of intermediate code. Symbol table is not the representation of intermediate code. Question number 115. Question number 115. Can you see this? Consider the following SDT. Okay. Consider the following SDT. Okay. S goes to 2AC. Next one. S goes to 3ABMC. C goes to 4. M goes to epsilon. B goes to epsilon. A goes to epsilon. He is asking, I think this question first, I think which one I have to give? Let me try. I think, yeah, this question first. Yeah, this question first. Right? Afterwards, we will go there. This is the first question. This is the first question. Consider the following SDT. Yes, A goes to ABCD. Consider the following SDT. A goes to ABCD. A dot I is equal to B dot I. C dot S is equal to B dot S. B dot S is equal to C dot S. If you observe clearly, A is getting from children's. A is getting from children's. A is getting from B. A is getting from children. Okay, that is called synthesized. Next one. C is getting from B. C is getting from B. That is okay. He is getting from sibling. Getting from sibling means inherited. This is a synthesized. This is inherited. This is inherited. But if you observe clearly, B is getting from C. B is getting from C. B getting from sibling, from right sibling. From right sibling. So remember in the inherited, you can take the data. You can take the data from, right? You can take the data from parent or from sibling. That is a left sibling. Right sibling you cannot take. He is taking from right sibling. That means this is not S attributed. It is not L attributed. Until here I can say, see, by seeing this I can say it is a S attributed. By seeing this I can say it is a L attributed. By seeing this one I can say you are taking from right also. It is not anyone. L attributed, no. S attributed, no. Both A and B, no. So answer is none. Yeah, someone is in TAC. TAC means? What is the meaning of TAC? So L attributed saying that it can use synthesizer and inherited, that's okay. But inherited from left only or parent. Inherited is right. So I'm repeating once again. L attributed is saying that you can use synthesizer or inherited, or both also no problem. But in the inherited, you should inherit from the parent or from left sibling, but not from right sibling. See, right sibling you are taking, that is the issue. From right sibling you are taking, that is the issue. From right sibling you are taking, that is the issue. So it is not L attributed. So because of this, yes, okay. Because of this, L, okay. Because of this, L is cancelled. Answer is none. Yeah, answer is none. Yeah, I think one more problem will do. Yeah, can you see this problem? Same question, same options. Can you try this? Same question, same option. Let me check. C is getting from A, no problem. Getting from sibling, left sibling. Left sibling means I think L attributed. Until now L attributed. Getting from either parent or from left sibling. So L. Next one, if you observe clearly, M is getting from A also, B also. M is getting from left siblings. No problem. No problem. Till now this is L. Till now this is L. Next one, if you go here, parent is getting from children's. S attributed, no problem. Synthesized. Parent is getting from children's. S attributed. Parent is getting from children's. Yes, it repeated. Parent is getting from children. Yes, it repeated. Overall, right? Remember, L can contain synthesized also, inherited also. Overall is L. Overall is L. So here inherited. Inherited means L attributed. Inherited means L attributed. So synthesizer means S attributed. Right? L contain S also, no problem. L contain S also, no problem. Right? So yes, synthesizer means L attributed also. Answer is finally L. Answer is finally L. So 115. Today approximately 15 questions we done. Today approximately 15 questions we done. 15 questions we done. In tomorrow's class, I am promising you, I will do minimum 20 problems. Tomorrow I will do minimum 20 problems. Tomorrow I will do minimum 20 problems. Right? 115. Tomorrow this time maybe approximately 135. Right? 135, something like that. Or 140. 135 or 140 we will do. Can I stop here? Can I stop here? I think there is some problem here. That is the reason I am stopping. Right? In the option there is some problem. Some problem is there. That is the reason I am stopping. 115 I am stopping. 115 I am stopping. Leaf by default synthesized. True. Leaf by default synthesized. True. Can I go? Can I stop it? Fine. These are the problems what we done today. Anything useful, please take it. These only will come in the exam. These only will come in the exam. I'm saying again and again. Few of the things will copy in the exam. Few of the things they will copy it in the exam. These only will come in the exam. Please go through it one time. What is the 3AC? What is the 3AC? 3AC means what? Let me know what is the 3AC. Three address code. You want to say 3 address code? 3 address code don't have implementation, but through quadruple, triple, indirect. So I think Shiva, you can send to me that question. You can send that question clearly. So I will check one time. If it is a reasonable question, I will explain in the tomorrow's class also. He is talking about last question. So let's check. This one, 3 address code. Which one of the following is not intermediate representation of source program? 3 address code is intermediate representation, right? No, 114. He's talking about 114. He's talking about 114. Not the 3 address representation. Not the 3 address representation. 3 address code is the representation of 3 address code, right? See, intermediate code, one of the representation is 3 address code. Intermediate code, one of the representation is 3 address code. That's one, right? 115. 115 area is the one, right? Where is the 115? It's a 114. I think 115 not there. Okay, it is a 115. It is a 115. Yeah, I got to know. I got to know. Right, Shiva, I got to know what you are saying. Shiva, I got to know what you are saying. Yeah, perfect. Perfect. Is it okay? Ella is asking something. Shiva, you send the question, right? If it is reasonable, tomorrow's class I will explain. Chalo. Thanks everyone. Good night. Tomorrow I will cover 20 more problems. Tomorrow I will cover 20 more problems. But remember, these only will come in the exam. Already in the EPT, 100 problems are there. Plus, I will cover here few more problems. Check. Thanks. Good night.